Good evening. So this is our next repair video. This is a Dell laptop that has a problem. The problem with this laptop is it will only start up if you reset the BIOS. So it's not quite a useful laptop if you need to keep on resetting the BIOS. So what I want to do in this video is try and figure out what is wrong with this laptop. So this may be quite a long video to get this laptop up and running. I don't know what has happened to it. I bought this as a broken laptop. I had a quick look at it. That's why it's all in pieces in a box. So what happens if I get too busy, I'll pack a laptop up in a box with all the parts together and see if I can get it sorted. As you can see, I tried new batteries, I tried a couple of things. Somebody was in this laptop before me. The reason I say so is that the fan that's in here is not original, and this was not done by me, and somebody glued the power lead in as well, and the fan wires are cut and soldered to the board. Yeah, real messy job. So it definitely comes from another computer shop. So what I did found on the board so far is that it had liquid damage. So the first step is to actually take this board, strip heatsinks, fans, everything off it, and go through the board with the microscope and see if maybe one of the resistors is faulty. That's all I can think of. The problem is this board don't have all the markings for the resistors. I did found a schematic for it, but without the resistor numbers on the board, it's going to be quite a mission to track down where the resistors on the board, or correlate where the resistor on the board is to the schematic. So this will be interesting. This may be a long video. This is not an easy repair, especially if it starts up intermittently. So let's get all this stuff back into the box. We don't need a box. Maybe I must just show what the board is doing at the moment, so you guys can see what I'm talking about, especially with the fan that's disconnected. So we put the Cmos battery back. So let's get this LCD out of here and plug the board back in to the laptop and show you exactly what it's doing at this stage. This laptop is a Dell. This was at a known repair shop here in Cape Town. This is I don't know why they hide these stuff. I don't know what model it is, because Dell, for some reason, changed the stuff on these boards, so it's difficult. You have to type in the service manual and stuff like that. So I'll find it. It's quite a nice laptop. It is an i7 with a Radeon card in. So I think what I'm going to do to save the hinges is unscrew the hinges from the LCD, so that we only can use the LCD and don't have to worry about the top cover getting in the way. So let's get started. So first things first, let's get this hinges undone from the laptop. These new Dell laptops, they tend to break the plastic inserts from the brass inserts from the chassis if you open them and close them too much without the screws that supports the laptop from the bottom. So let's just chuck all that into there. I'm going to need to remove the power button. I'll use that as well. Unclip that, get the button loose. Let's get that hinge up, and I actually need to glue this in. I'm going to fight with getting that power jack out quickly, because I'm going to need it for doing tests on the board. So we can take the Wi-Fi antennas off, because we're going to need to remove it. There we go. Get off the LCD, the power button. So I'm just going to move this LCD out of the way. This poor laptop's top case is not in a good condition. It does have a lot of scratch marks and stuff like that. So let's get the LCD out of the way and fight with this power button. Let's see if I can maybe take a screwdriver, just jam it on the side here, just to see if we can get this plug, there we go, out. We'll have to super glue that back again. So we put that out so we can remove the top cover. So let's get nope, not that way, must be this way. Okay, let's back in. Let's plug in the power button. So get the LCD here, and I'll also need to Remove my Mac charger. And find my clover plug. Good. Got my clover plug. So I'm not going to use a power supply for this one. The reason for this is that on the Dell machines, it's got a identifying pin to identify the charger. So let's see if we can get this focused. It's quite difficult to see. You got the outer shell, which is negative. There's the inner barrel, which is positive, and then it's got a center pin. And that center pin is the ID pin. So we need the ID pin for the laptop to charge up. I've tried several different chargers, and they all do the same. So let's get the LCD plugged in, and I'm going to power up the board. The fan is not going to work because the fan wires are off. So let's see if it will start up. Nope. Let's try it again. Okay, we've got a power light, it went out. And nothing happens. So let's unplug this. Let's take the battery out. Let's do a 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 seconds reboot. Let's plug in the battery again. Plug in the charger. Okay, let's try it again. Five seconds. 1, 2, 3. Now you're gonna make me lie in front of the camera. Come on. Just want to get the image. Still nothing. Let's try it again. Now we got the power LED on. Just went off. Let's give it a few seconds. Because these Dell, all this strange stuff sometimes if you remove the battery. On, off, on, off. There we go. See, it's on now. And it will actually boot into Windows and everything if the hard drive is connected. But if we, there we go. So it shows that the display was reset. Oops, I just moved this. If I switch it off, 1, 2, 3, 4, 5, or that's off. If I try to switch it on again, it won't go on. No matter what I've tried, I don't get this laptop to switch on again after this. So that's the fault. So as you showed, I'll show you that's a fault on this board, and there's no trickery or whatsoever. So hopefully we can get it to work. We could try to unplug the charger again, plug the charger in again. Let's see, power light is on. Still on, and it would not post. Or start up. Post means power on self-test. For those who don't know. So there's a power light is out again. Let's try it again. 1, 2, 3. No power light. So laptop's dead again. So I think this board was water damaged. Somebody repaired it. And I think what happened is one of the pull-up lines is corroded away. That's my theory. Might be wrong. So when you reset the BIOS, what I think happens is that line that's low gets pulled up somehow. Either through the EC or system management chip or Super IO chip. This chip's got so many names. I prefer EC because it stands for Embedded Controller. So I think what happens once the power is plugged off, or once the BIOS is reset, that line gets pulled up, maybe by the chip or something, and then the board will start. But we can try to unplug this in, plug it out, plug it in, plug it out, as we wish. This board will not start up. If you take out the little backup battery and put it back, the board will start up again, and the laptop will work fine. Let's do it. Let's remove the battery again. Charger is disconnected. Go. Put it back in again. Let's just plug in the power. Power light is on, off. It should come on again. on, off, and it should come on again and start the laptop up. Off now, on, and we should have the image on the board. Right about. It can also be that every single, there we go, there we're on again. There we start up. It can also be that every little power supply, like 3.35, 105, GPU power, it's got a power good signal. And that power good signal could be feed back into the board. That feed can also cause this problem that it's not a good power good, but I don't think so. I think one of the signal lines are not pulled up properly and will cause this. So we can switch it off. 2, 3, 4, 5. There we go, we're off. And we can try to switch it on again. No power light comes on, nothing, it's dead. So let's see if the first thing I want to do, see if we have, oh, is this thing in focus? It's not there yet. Let's see if we got, yes, we do have 3.3 at the power button, and let's see, there you go. So that's a power button. You can definitely see it pulls the signal low, but still not switching on. Alright, so let's get the LCD out of the way. Let's focus on the board. And I think we go under the microscope straight away. I'm going to strip off the heat sinks and stuff, and then we take it from there. Okay, so I got the board removed. The next step is let's go under the microscope and see if we can see anything that's wrong. I just took the heatsink off. I'm going to take out the battery as well. I took off the power button. The less wires hanging off this, the easier it is to rotate. So let's go on a microscope, scan across the whole board, see if we can see any dodgy connections, and then we can come back to this. Alright, so we're under a microscope, so let's have a look if we can see something. What I'm looking for is any signs of corrosion. I'm just going to scan through the board. So I'm looking for any brown or discolored parts on the board. So I'm just scanning up to the processor, and then I will scan from processor up again. Like I said, this is one of the most difficult repairs to do. Look at all these little soldables on the board. That's crazy. That comes from a manufacturer. It's not something that happened afterwards. See, there was some liquid. Maybe this was flux when they messed up the connector. So I have to sort that out as well. Getting close to the top of the board. Alright, so that's one side. Let's do the other side. Let's see if we get nice and focused. There we go. See if we can see anything. I'll show you that nice and ugly solder in a minute. So some paste, thermal paste residue on the board. Oh, okay. Look at this wonderful soldering of the fan connected to the board. Man, that's horrible. Horrible, horrible, horrible. Okay, let's keep going. Shift my mat up slightly. So good. Here was some liquid damage. You can see these caps are slightly discolored. So you just have to check all these little resistors around here. That will look fine. This side, if you've got some more components than the other side. Oh, we are missing resistor or something here. That's somebody was here, somebody soldered here as well. We'll have to check out that pad. But it's going to be difficult without knowing where the trace is going to. We'll probably have to reverse until we can find what is that component missing there. Maybe we can see, oops, sorry, what if this is some pull up or pull down resistor or something. So that's definitely could be one of our problems. There's some more liquid damage here. So you got that one bad spot at the CPU so far. What I'm doing is I'm just checking if you can see any other bad spots. That solder joint looks factory, so it could be that something corroded away this pad, but that looks definitely like factory, so I don't think there was a component there at all to start off with. Okay, here we had some liquid damage, still some flux on the board. We'll check these out as well. Just because I think the embedded controller system management chip is on the other side, so we'll have a look there as well. Let's keep moving. Bars. Make sure all that is fine. It's the last edge of the board. So I don't know how much you missed now. The phone just died. It was a full battery, but it looks like we're missing a component here, and trace that. It's not going to be easy. I'll need to see where that little point is going to, and then the other one was down here that somebody soldered as well. What I'm going to do is going to test that resistor quickly, both of them. So this one here has 10 kilo ohms. It looks fine. This one here is 100 kilo ohms. So that resistor looks fine. So that's 100. That's 10. That's two values that could be completely right. Yeah. All these resistors, it's either 100k or 10k, which is 100%. So those are looking fine. So the one I'm concerned about now is this one there. It could be a no stuff component, which means there was nothing ever there, or there could have been a component there. Now the problem is we'll need to trace with that little wire. This little wire is going to on the other side of the board, and see if we can find it on the other side of the board. So that could be the problem. That could be a pull-up. Let's see on continuity if one side of that cap is going to ground. Yes. And the other side is positive. Yes. So there could be a resistor that goes from here to here. Now if I look as this is a positive line, so here's another resistor right next to it. I wonder if this resistor is maybe the same value as that one. It could be, because they could both be pull-up resistors. So let's measure this one. That's a 10k, so that's definitely a pull-up resistor. So if this was a positive line, I think this should also have a 10k resistor. Most of these resistors will be pull-up resistors. So we can go with a guess and try to that pad is completely destroyed. Let's zoom in again. Refocus. This pad is completely destroyed. There's nearly nothing there to solder to. Wonder if we're going to get a reading of that pad. Yes, we still have a reading of that pad. Okay, let's just see if we can find something sharper so we can just open up that little point in the center. Maybe we can get a little bit more of a better connection on that. on that little point over there. So you find a sharper one. Let's see. All we're going to have is that little piece there in the back. Let's see if we still got some connection. Yes, we do. Let's get the soldering iron up and running. What I'm going to do is see if we can get something to solder there, and then find another 10k resistor. That's all I can think that should go there. Otherwise we're going to need to track down what is the right resistor, but I think 10k should be around about right. So that back part is still connected, and that's all we've got left, is that little back part over there. Okay, so let's see if we can find the 10k resistor to repair that. Okay, so I found one. I'm just going to remove it from the board quickly. So just remove the resistor from the donor board. I don't want to use heat here because of the CPU sitting right next to it. So all I'm going to do is use some flux. Yeah. And now we need some thin wire to create a little bridge, a little jumper. I just lost a little jumper. Use this to create a new jumper. Oh, this wind is howling outside tonight. I'm just temporarily soldering it there. Get some flux in there. That should do it. I don't want to mess around too much with that little jumper over there because it's hanging on by a thread. Just clean this off. Unfortunately, let's switch back to the main camera and let's plug in some RAM and a battery and see if we can actually switch it on. I need to get the ring light so I don't have that much glare on the board. So we focus it down there. So all I'm doing is just putting in the battery, and let's plug in the power. We have a power LED on, went off, should go on again, off again. LED is right here by my finger. Still off, on. Okay, we should be off again, and then the last time on. And normally on that we have picture. There we go. Now it should stay on. We can see if we've got CPU is cold. Let's check the CPU for voltage. It's nothing, it's off. So it doesn't look that if that fixed our problem. We do have 3 volts on that side. Still nothing. So 3.3, got 5 volts. Still no power. So let's unplug this and replug it. Still nothing. Let's keep that plugged in. Let's unplug the Cmos battery. See if we still have 3 volts at the CPU, at the power button. Still nothing. So we're still not powering on. Let's see if it still does the same thing when we plug in the LCD. Alright, so after hours and hours of battling to find the fault with this Dell board, I eventually found the fault. So let me just put the battery back in the board. So I'll put up a diagram of what the fault is here. So on the Dell laptops you need RTC voltage to be present on the EC chip for the RTC circuit, real-time clock circuit. And what is happening is the coin cell battery comes in here, and here we are getting 2.8 volts. Let me turn on the multimeter software. Right, so now we've got the multimeter software up. So here's the input voltage. The battery is slightly flat, 2.83 volts. Now this goes through this double diode. Now what this double diode does is, once the system is powered up, it puts 3 volts through this pin into the system to run the system, so it doesn't use the coin cell battery as much. But you can see we get 2.1 volts here, and then at the output only 1.8 volts. And that boggled me. I couldn't understand why we only get 1.8 volts here. Yes, here's a voltage divider, which is a 10 meg ohm and a 1 kilo ohm, and that still should give us 2.8 to 3 volts easily on here. but the output is only 1.8 volts. Now 1.8 is too little. And what I found is that, let's test this diode quickly. Let's remove the battery, the little Cmos battery in the back, and let's test that diode. So this diode's got two inputs and one output. So it's got a diode from here to there and a diode from here to there, so current only can flow that way and the current only can flow this way. So let's go to diode mode. So let's test this diode. So we should have, this is the negative probe that goes here, and the positive goes in. So we have 0.6. Oh, that looks like a normal diode. So what do we have on this side? Come on. It's not plugged in or anything. We also should have 0.6, but for some reason my multimeter don't want to read this. There's nothing on that side. There's nothing on that. Okay, that's strange. I had a reading of 0.3 over there, or 0.6, but there's no short over there, so which means this diode is not shorted. So the helps if I measure the right one. To measure here, you see 0.3. You measure here, you see 0.3, right? So that means the diode is right. If we measure between these 2 points, we should have nothing, which is correct. And if we reverse the probes, we should have nothing, which is correct. But let's put in the coin cell again. Let's go back to voltage. So here I have my 2.1 volts. Here I have 1.8. And look here. I still get nothing, right? So I was thinking that diode is fine. But the 1.8 volts still bothered me. So what I did, I took my power supply and I set it to 3.2 volts. And what I'm going to do is connect my ground of the multimeter to ground. And I'm going to inject 3 volts here, which should be the coin cell. As you can see, I still only get 2.3 volts here. And on the output, I get 2. But still nothing on here. But if I skip that resistor, come on, That's strange. 3 volts, 2.7. But what was no, it doesn't show on camera. Murphy's Law. But what happened is I only get that 1.8 volts. Let's put the coin cell back in, and you'll see we only get, we're getting 2.4. So I just blew up this That's strange. There we go. We only get the 1.8 volts. We don't get the full 3 volts on this diode. So I'd look at the circuit diagram. I'll post the circuit diagram on here as a photo, and I'll show you the diode what I was talking about. So for some reason we are losing roughly 1.2 volts. That just goes somewhere. So out of frustration, I start to check all these components. This MOSFET over here, and this double diode over here. Now this double diode, when I was testing with the multimeter, would give me a backfeed voltage into that third pin. So onto this pin here, I would have got voltage through, reverse voltage back into that back through that MOSFET. So let's turn this one off, which was strange. I couldn't understand why I'm getting feedback. So of course it doesn't want to show it on camera. So I just replaced that little dual diode. Let's clean up the flux. Alright, it's nice and clean. Let's put in the battery. So this laptop wouldn't start up. It would not, it refused to start up. So let's see, after we replace that diode, what's our input voltage now? Did I put the wrong battery in? Yep. I put the flat battery in. Another thing I couldn't understand, that battery was testing properly, but it was flat. So let's see. You get 2.3 volts, 2.8, 2.3, and nothing. Okay, let's plug in the power. We have power light. Should go off, on, off. It's on. So we got 3.3, got 2.9, 3.3, 3.2 volts on that line. Let's check CPU recall. Okay, we've got CPU recall. Right. Let's switch the laptop off. 1, 2, 3, 4, 5. That's off. Let's check CPU recall again. Okay, that's off. Let's check this voltage here. We still got 3.3, 2.9. So that looks good. Let's see if we can turn on the laptop again. Let's press the power button and then the laptop goes on. There we go, CPU recall. Let's switch it off. 1, 2, 3, 4, 5. That's switched off. No CPU recall. Let's unplug the charger. So let's plug in the charger again. It looks good. Let's check the power light. So you guys can see the power light over there. And there we got power light. So the whole problem with this board was, we got CPU vehicle, was that little diode that was killing the board. So what happens is on the Dell laptops, it is looking for the battery, the coin cell battery. This was even got written GOG, which most probably means for good. So the coin cell battery keeps a real-time clock, but that line runs to the Super IO or embedded controller chip or system management controller chip on the board, and that keeps it running. And I think if it reaches 1.8 volts, it stops the processor from running for some reason. It's strange. I don't know why Dell did this. This battery voltage even runs to the power button. So if you don't plug any charger or any power adapter or battery in here, it would actually give you 3.3 volts on the power button. Strange, I know. So I think it's a way of monitoring if the battery is fine. It also goes to a certain pin on the EC chip as well. I mean, I've went through this board numerous times trying to sort this problem, and spent up to 4 o'clock in the morning yesterday. But yeah, can't believe that that little diode messed it up. So now I just need to assemble it. I will assemble it on video and we can give it a test and make sure it's running. I learned something new. I hope this helps somebody else as well. I was in numerous forums. Everybody just couldn't understand what I was talking about. That the laptop would not power on after BIOS reset is done. So next time we going to assemble a laptop and we take it from there. Okay, so it's the next day, and I left this board on my table overnight, just on the Cmos battery. And what I want to do is I want to see if this board still starts up after one day with any voltage, only the Cmos voltage connected. So let's see. You guys can see that. So let's press the power button. We've got a power LED on, which is here in the bottom. And we have CPU VCore, which means this board is fixed. So if it was standing here 24 hours without any power connected and still starts up, I'm calling this board fixed. So let's start assembling this board back together again. Get it back into the casing. I got a new BIOS battery which I want to put in, because this one is 2.8, which is not bad, but it's better to put a fresh battery, especially this is a stock laptop, so this is definitely going to be sold. Let's clean up the old solder thermal paste. The only one thing I don't have, and which I would actually really like to have replaced, was this dodgy fan thing they've got going on here, but I don't have a plug like that. So we'll have to do the next best thing, and that's just solder the fan wires back on it. I'll just do a neater job than what these guys did. That's unfortunate, but at least it should work. So let's put back this little bracket. There we go. That's way too much. I like to just push it down a little bit. to cover the complete die. A little extra won't damage anything. People are paranoid about putting on too much heatsink compound. Let's just get my screwdriver. 1, 2, 3. Back to 1, 2, 3. And then GPU. Don't over tight them. Don't need to over tight them. Alright. So let's get these wires soldered back just a bit more neatly. I'm going to do that under the microscope so you guys can have a better view. So just get these wires out. And let's switch over to the microscope and we can take it from there. So look at that pretty soldered job that somebody have done on that connector. Oops. It's a nice and dodgy connection done on this. So this old wire away. Let's clean this up a bit. Let's get this wire nice and trimmed again. Okay. Let's remove this ugly here. Right, and then the last one is that center pin. Alright, so that's the 3 wires back. We're just going to tuck these wires out of the way so they don't interfere with the screw hole. That should be okay. Let's just clean off all that nasty flux that was left behind by the previous guys. Okay, that looks much better. So now we can move back to putting everything back together again. Okay, let's put in the power button first. Power button back. Let's get the LCD. Just get one screw on each side. These little arrows that show you where the screws goes in. I'll give you now a close-up shot of that. Come on. Okay, let's grab the two hinges, push the cover down. Oops. Before we do that, let's just get our somebody messed up here. No surprise. Let's open up this hinge. This cable. cable must go in the bottom. I think got a similar problem on the other side of the hinge. Let's just take this first. Remove this one. Let's open it up. So that's the little arrows I was talking about that shows where the screws goes in. There. And then here's some hooks for the wires to get routed through. So I'm going to do that quickly. And these are stuck down in these little flaps like that. This cable should go in there. We can insert a motherboard. First we need to plug in this I/O board, which we can just do from here. Swing this around, put that wires on the top. It's back into position. Okay. You don't have to install the wireless LAN module now because this gets screwed into the case. one should go here. There. There. 2x3 more. Need one screw over there. I think this is the only screw that goes in there anyway. I think there's other inner screws, but you can check the bottom casing. Up. That's the only screw for there. I'll get to the battery. Yes, okay. Alright, so we can screw the bottom case back. We just fix these speakers first. This one. And I just pulled out this one. This little rubbers, this little, like little shocks absorbers for the speakers, so it doesn't put vibration into the casing. There we go. Okay. Now this cable goes through this hole over here on the top. These two cables goes over there. And this cable plugs in there. But before we do that, I just want to add some little bit of hot glue in there. If you can find my hot glue sticks. There we are. So what I'm going to do is heat up this glue. Put a dab of it in there. Push the power button down. Add some in the back for support, and that should do it for the hot glue. Okay, it's all seated properly. So these screws should be for the hinges. These ones are 5mm. This one here is a 5mm. And the center one is a 5mm. So it's a 2.5 by 8mm, which is a long screw. This one over here is a 2.5 by 8mm. Okay, let's see. 2.5 by 8. This one's got no marking. This is a 2.5 by 8. This one over here is a 2.5 by 8. This is 2 more screws, which I don't have in this container, so that means there were never screws for there. We can put our Wi-Fi module back. 2. A little plate back. Put a screw in. So I need to get some screws for the bottom of the DVD drive. Need to sort that out. We can add our extra RAM strip in here. Put the hard drive back. Which also uses long screws. Okay. And now I'm missing one screw there, and let's get this cable back in. Get the power button back in. So this laptop short some screws. So so I'm going to fully assemble this. I'll just put back that needs to be put back. Have a load of screws at the shop. So it's loosely fit that. We can plug in our charger. We have a light. Let's press the power button. And we have image. So the big thing was turning it off. 3, 4, 5. Okay, this is a faulty charger. Right. This is a continue. Goodbye setup. Okay, let's go exit. Okay, it's off. Power it on. There we go. All sorted. So that little diode was the problem, that this laptop would not turn on. Can't believe it. I was just moaning about my Dell charger. It can't read it properly. That could be a faulty charger. It's one I use in the workshop, so I don't think there's Windows on here anyway. Yeah, it just reboots because there's no Windows on this machine. You can go continue, it will reboot the whole time. So I'm calling this a fix. I am going to replace the Cmos battery, this battery over here. I want to leave the power jack plugged in. Let me just get that quickly. Okay, so new battery. Let's see what the voltage is. 3.4 volts, so it's a nice full battery. Let's put in the new battery. Switching one. And that's it. Thanks for watching, and see you in the next one.